Topic 9, Ecology. My name is Joshua Mugabi. I welcome you to Topic 9, Ecology. We are going to look at Learning Outcome C. Examine the concept of energy flow through ecosystems, its role in maintaining ecosystem stability, and the impact of human activities on energy flow. We are going to look at the learning activity C. Learners carry out a scientific investigation on feed conversion ratio in a small mammal, like a rat or a rabbit, using different deities. Learners write a report and present it to the class in a plenary. Let's look at scientific investigation, feed conversion ratio in small mammals. Item 1. We are going to look at planning the investigation. A school biology class wants to investigate how different deities affect growth in rats over 4 weeks. Task. State the aim of the investigation. Formulate a hypothesis. Identify independent, dependent, and controlled variable. State the aim of the investigation. The aim: to determine how different diets affect feed conversion ratio in rats. Formulate a hypothesis. Our hypothesis: rats fed a high protein diet will have a lower feed conversion ratio, more efficient growth than those fed on a high carbohydrate diet. Identify independent, dependent, and controlled variables. Variables. We have independent variables, that is the type of diet, for example, high protein, high carbohydrate, or mixed feed. Dependent variable, that is weight gained by the rats. Controlled variable, we have the age of the rats, initial weight, number of rats per group, housing conditions, water availability, feeding schedule. Still under scientific investigation, feed conversion ratio in small mammals, item 2. Now we want to look at selecting and preparing experimental materials. Students select healthy rats of similar age and weight for the experiment. Task: explain the criteria for selecting experimental animals. State why it is important to have equal numbers in each group. Explain the criteria for selecting experimental animals. Rats should be healthy, of similar age and weight to reduce variability. State why it is important to have equal numbers in each group. Equal numbers ensure fair comparison between deities and reliable statistical results. We are still on scientific investigation, feed conversion ratio in small mammals, item 3. We are going to look at designing the experiment. Students randomly assign rats into 3 groups, each receiving a different diet. Task: describe how to randomly assign rats to group. State why randomization is important. Describe how to randomly assign rats to groups. Assign each rat a number and use a random number table or draw lots to determine groups. State why randomization is important. Randomization reduces bias and ensures results are due to dietary differences and not other factors. We are still on scientific investigation on feed conversion ratio in small mammals. We are on item 4, and we are going to emphasize on measuring initial data. Before feeding, students record initial body weight and feed or fat. Task: explain how to measure initial body weight accurately. Record starting feeding amount for each group. Let's start by explaining how to measure initial body weight accurately. Use a sensitive weighing balance. Weigh each rat at the same time of the day. Record starting feeding amount for each group. Ensure each group receives the same amount of feed. Scientific investigation, feed conversion ratio in small mammals. Item 5. Let's look at feeding and observation. Rats are fed their respective diet for 4 weeks daily observation are recorded. Task: list daily observations to monitor. State why consistent feeding time are important. List daily observations to be monitored. Feed consumed, leftover feed, rat health, behavior, and water intake. State why consistent feeding times are important. This ensures uniform conditions and reduces stress-related variability. Scientific investigation, feed conversion ratio in small mammals, item 6. Let's look at measuring final data. At the end of 4 weeks, students measure final weight of each rat. Task: record final body weight. Measure total feed consumed per rat or group. Record final body weight. Use the same weighing procedure as initial measurements. Measure total feed consumed per rat / group. Calculate total feed offered minus leftover feed. We're still on scientific investigation, feed conversion ratio in smaller mammals, item 7. And we are going to calculating feed conversion ratio. Students calculate feed conversion ratio for each group using the formula. Feed conversion ratio is given by feed consumed in grams over weight gained in grams. Task: calculate weight gained for each rat. Calculate feed conversion ratio for each dietary group. Interpret which dietary is most efficient. Calculate weight gained for each rat. Weight gained is given by final weight minus the initial weight. Calculate the feed conversion ratio for each dietary group. Feed conversion ratio is given by feed consumed divided by weight gained. Interpret which dietary is most efficient. The diet with the lowest feed conversion ratio is the most efficient at converting feed into body mass. We are still on scientific investigation, feed conversion ratio in small mammals. We are on item 8. We shall look at data presentation. Students tabulate results and plot a bar chart of feed conversion ratio against diet type. Task: prepare a table showing initial weight, final weight, feed consumed, weight gained, and feed conversion ratio. Draw a bar chart to compare diets visually. Prepare a table showing initial weight, final weight, feed consumed, weight gained, and feed conversion ratio. Our table, we have the diet type, high protein, high carbohydrates, and mixed. We have the initial weight in gram, final weight in grams, feed consumed, weight gained, and food conversion ratio. Those that were fed on high protein, the initial weight was 100 grams, the final weight was 140 grams. The feed consumed was 160 grams. Therefore, weight gain was 40 grams and food conversion ratio was 4.40. Those that were fed on high carbohydrate, the initial weight was 100 grams, final weight 130, feed consumed 150 grams, weight gain 30 grams, feed conversion ratio was 5.0. Then we had a diet which was mixed, and the initial weight was 100 grams. The final weight was 135 grams. Feed consumed in grams was 150. Weight gain in grams was 35, and the feed conversion ratio was 4.43. Draw a bar chart to compare diet visually. Bar chart shows feed conversion ratio values. Lower bar indicates more efficient diet. Still on scientific investigation, feed conversion ratio in small mammal, item 9. This time we are interpreting or interpretation and conclusion. Students discuss results in relation to their hypothesis. Task: state which diet produced the most efficient growth. Explain the biological reason for the result. Suggest improvement for future experiments. State which diet produced the most efficient growth. High protein diet produced the lowest feed conversion ratio, which is the most efficient. Explain the biological reason for the results. Protein supports muscle growth and overall weight gain more effectively than carbohydrates. Suggest improvement for future experiments. Use larger sample size, longer duration, or different age groups for validation. Scientific investigation on feed conversion ratio in small mammal, item 10. Let's look at reporting and ethical considerations. Students submit a report including methodology, results, and conclusion. Task: state 2 ethical considerations when using rats. Suggest how the investigation can be applied in agriculture or aquaculture. State 2 ethical consideration when using rats. Handle rats gently, provide adequate food and water, minimize stress, and avoid harm. Suggest how the investigation can be applied in agriculture or aquaculture. Feed conversion ratio data helps farmers choose efficient feed, reducing costs and improving production. Key learning outcomes: understand and calculate feed conversion ratio. Understand the relationship between diet, energy efficiency, and growth. Apply scientific investigation skills, planning, data collection, analysis, and implementation. Appreciate ethical treatment of experimental animals. This is topic 9, which is ecology. Thank you for participating in topic 9, ecology. Our learning outcome has been C. Examine the concept of energy flow through ecosystem, its role in maintaining ecosystem stability, and the impact of human activities on energy flow. We have been looking at learning activity C, where learner carry out a scientific investigation on feed conversion ratio in a small mammal, the rat or rabbit, using different diets. Learners write a report and present it to the class in a plenary. If this has been very useful to you, please visit me at Mugabi Joshua Biology on YouTube.